In our final addition or subtraction example, again we have two fractions or rational expressions that do not have the same denominator. In order to find the least common denominator, we look for a least common multiple. Well, to do that, I'm going to break each of these denominators down into factors if possible. The denominator on the right, 5x squared minus 10x, I think I could rewrite as 5x times, in parentheses, x minus 2. So I factored out a greatest common factor of 5x from each of those two terms that I saw. So I have a 5, I have an x, and I have an x minus 2 as factors. The denominator on the right, I see a 10x squared. Well, the 10 I could rewrite as 2 times 5. Now you wouldn't necessarily have to do this, but I'm going to do this just to make sure that we notice which factors we have and which ones we don't need to repeat. So I have a 2 times 5 times an x squared. Now, the least common denominator will be the least common multiple between these two expressions. Least common multiple will be the product of each factor the greater number of times that it appears as a factor. So I have to look at all of the factors that I have listed here, and I see that I have a 2 as a factor once versus I don't see a 2 over here. So that means a 2 will be part of my least common denominator. I see a 5 as a factor here. I also see 5 as a factor here. If it's just repeated, I only see it once here, once here. I only have to include it once in my least common denominator. The next up would be the x squared. I have two x's as factors at making up x squared. I see just one over here. Well, I'm supposed to choose it the greater number of times that it appears as a factor. Therefore, I choose x squared versus just x. Now, the last factor that I have to include would be this binomial factor, x minus 2. I don't see an x minus 2 as a factor over here. I do see it right here, though, so I do have to include that as a factor of my least common multiple or least common denominator. Putting these together, the 2 times the 5 gives me 10, so I have 10x squared times x minus 2. This is the denominator that I would like to see in order to add these two rational expressions together. Now, I'll write that over here so we remember this is what we want for a denominator. 10x squared times x minus 2. Now, thinking about how we turn each of these fractions into a fraction with that denominator, focusing first on the fraction on the left. I'm going to erase this just to make some room. I see that I have 10x squared as a denominator. I'm supposed to have 10x squared times x minus 2. Well, that means I'm missing the x minus 2 factor. So I need to multiply both the numerator and denominator by that missing factor, x minus 2. Moving on to the second one. Now this one, again, I erased it. I'll rewrite it in factored form just so we can look at it and think about what factors we're missing. Now I notice that I have the x minus 2 that I need. I've got a 5 and I have an x. Well, I need to have 10x squared. Well, to turn 5x into 10x squared, I would have to multiply by 2x. The 2 times the 5 will make it 10. X times x will make it x squared. And then I'll have everything that I need for my common denominator. Now, if I multiply the denominator by 2x, I should also multiply the numerator by 2x like we've been doing. Putting these all together, I have my common denominator that I need. So now I'll focus on the numerators. On the left, 3 times x minus 2 will give me 3x minus 6. I'll write that over here. 2x times 2x is going to give me 4x squared. I'm adding whatever happened here, so I will put plus and then 4x squared. I've got everything added together. There's no like terms here, so the last thing that I would probably do is just rewrite it so that it was in descending order of exponents. 4x squared plus 3x minus 6 all over 10x squared times x minus 2. I'm going to guess that there's no common factors that I can pull out and cancel, so therefore we're going to go ahead and leave this as our final answer.